So let's restart this particular lessons right here. Once again, we do have 3 lines, and the 2 lines, purple and blue, are actually parallel. Okay, I'll actually give you the preconditions. They're parallel lines, and the orange line is actually perpendicular to the blue and the purple. To write an equation of any given line, you need a minimum of 2 points to begin with. Is that true? And I actually gave you the bare minimum. From the 2 points, what do we need to find right away? The slope. Please have that written down somewhere so that, hey, if I ever need to find an equation of a line, I need a slope right away. And how do we obtain a slope? We need 2 points. Is that true? So if we have the 2 point, which is at -3 and 3, and we have 0, 8. Is that true?
No, it's 3, 7.
Oh, sorry, 3, 7. I got the other one. 3, 7. What is the slope then? Let's subtract it. What's the slope? -6 over here. -4. Okay, and how do we put these together?
Rise over run.
Which is?
4
-4 over -6. Rise over run. Very good. Can we simplify, or is it okay as is? Simplify. How do we simplify -4 over -6? 2/3. Okay. Now, I want you to do me a favor. Since you already have the graph and you have a slope here, verify right away if the slope is correct. And the way to verify it is actually going back to your graph. Look at the line. Start at the anchor point right here and see if you can actually use the slope to get to another point on that same line. So watch. If I start right here and I go where? 2 up? 3 where? Right. Do I have my point on the line? Yes, I do. Look at this. 2 up, 3 over. Guess what? I have the point on line. So that's how I know my slope is actually correct for this line. See that? Okay. Now that we looked at it, like, wait a minute. I know we're supposed to find the y-intercept, right? Well, what do we happen to find right there? What is this point right here?
Y-intercept.
Oh, it is actually on the y-axis, and it is the y-intercept, isn't it? And what point is that?
1, 2, 3, 4, 5, 6, 0, 6. 0,
6,
6.
0.
How do you get 6?
0, 5.
I counted the lines.
No, you start from, this is 0. So 1, 2, 3, 4, 5, right?
5.
So 5. So if it's, the y-intercept is 5, what letter represents the y-intercept again? I forgot.
5.
B.
Wait. Oh, yeah.
Right? B is 6. So if we have M and we have B, what can we put together? How do we put this?
Equation.
I thought it was 5.
Oh, sorry. See? Marvin, you messed me up.
Yeah, I do.
5. Sorry. 5. Now what? How do we put this together as an equation? Okay, so we have this format, and then how do we put this in?
Substitute it.
Substitute what in?
The slope and the y-intercept.
Thank you. So how do we write the equation again?
Y equals 2/3 times plus x plus 5.
Good. This right here, guys, is your slope-intercept format. Is that difficult? Is that difficult? Okay, so if this is your slope-intercept format, can you tell me how do we convert this back to standard form?
You get the variables on one side.
Yeah, how do we move all the variables to one side? What do we need to move over specifically? It's the 2/3 x. Good. How do we move the 2/3 x over?
Subtract.
Good. So if we subtract it over, can I make room for it? If we subtract it over, do you agree that your new equation is going to look like this?
Yes. Yeah.
You haven't seen it yet.
No.
There. Do you think it's going to look like that?
Yes. No.
No. Wait, what?
Yes. No.
Because I move it over,
Yes. No.
right? Look at this right here. If I move the 2/3 x over, don't I have to subtract it? And if I subtract it, will it look like that?
Yeah.
Is that correct?
No.
No.
Jose, why no?
Because it has to be positive.
Okay, no, I'm talking at current
it has to
state.
be an
At the
integer.
current state, is it okay the way it is?
No.
We're not finalizing yet, but I'm saying, did I move it correctly?
Oh, yeah.
See, that's what I'm asking. Did I move my variable correctly?
Yeah.
I did. So now, is it in standard form, I ask?
Yes. No. Yes.
Is this in standard form?
Yes. No.
Okay, how do you make this into standard form? Yes.
You times everything by -3.
Why -3? What's your reason for it?
Is,
You have to make
the least,
What are you trying to achieve by times it by -3?
turn it into an integer.
Yes, so basically your goal is to get rid of all fractions and get rid of the negative in front. Is that correct?
Yeah.
And that's right. You are multiplying the whole thing by the
Negative.
LCD, which is this base of 3. But because it's a negative to begin with, and I don't want negative to begin, I have to multiply by the negative as well. So if you multiply it in, what do you have?
2x
2x
minus
minus
Y
3y equals,
negative 15.
thank you. And this right here, guys, is your standard form. So let me go ahead and write this down here for you, up here, over this side. So the slope-intercept form is 2/3 x plus 5, and the standard form is 2x minus 3y equals to negative 15. Okay, we're all cool with that?
Wait, what was the top one? That one's...
It's over here. I just move it over.
Oh.
It's 2/3 x plus 5. Okay, and it reflects what we have here. Notice the anchor point is on the y-axis at 5, and then we go 2 up, 3 over to get to the other point. So it's exactly what is described. You see that? So that's for the purple line. Now, let's do the same thing now, but I'm going to go ahead and start with the blue line. What do you notice about the blue line? Let me show you a trick on this, okay, to help you speed up your process. We know that we can actually obtain the slope by either subtracting 2 points, or if you already have a graph on here, can we actually use the rise over technique from one point to get to the other?
Yes.
Okay, so let's go back to the blue line here and tell me, how do you get from this point to that point? So describe the step that you will take to get from here to here. Rise how many?
6.
1,
Wait.
2, 3, 4. So you said to rise 4. So I'm going to go ahead and keep track of that. This is rise over run. You tell me to rise 4, right? Okay, and then where do I go now? 1, 2, 3, 4, 5, 6. So to the right 6 meaning run 6, right? If I reduce that, what do I have? 2/3. Okay, so I got my slope. Do I have my y-intercept given?
Yes.
What is it?
0, -3.
Which is? B is? Thank you. So I got my M, I got my B. What can I put these two together? To form what?
Slope and slope.
Thank you. Slope-intercept format. So notice I'm writing this again just to remind you what the slope-intercept format looks like. And how do we rewrite this form?
Y equals 2/3 x plus negative 3.
Or
Minus 3.
can we just do that? Plus negative means minus, right? So we can just go ahead and eliminate the plus sign. So this is your slope-intercept format. And how do we take this slope-intercept format and convert it back to standard? Same time. Yes, how?
Subtract 2/3.
So I subtract 2/3, so it's going to look like this. Okay, right?
Yeah.
Why is it, let me ask you this question, why is it that I have to put negative 2/3 x? Why do I have to put the negative 2/3 x in front of y and not in the back?
The variables have to be in order.
Thank you. The variable has to be in order. Perfect. Now, are we done?
No.
What do we need to do?
Multiply by negative 3. Multiply by negative 3.
Okay.
Multiply the whole thing by negative 3.
Okay, we multiply by negative 3.
The whole thing.
The whole thing by negative 3.
Yeah.
There we go. Why?
No.
Because we have to clear the fraction, remember?
Oh,
Okay, so let's multiply. If we multiply it in here, what do you get? 2x. Over here?
Minus 3y
Okay.
equals 9.
Okay. So I have the information that I gather right here, and then can I go back to the blue line and write this? Watch this.
What form is that? 2x
Huh?
subtract 3y. Standard?
This is standard. Remember all the x and y on one side? Okay, so we have y equals to 2/3 x minus 3. That's your slope-intercept. And then 2x minus 3y equals to 9 as your standard form. So I'm going to go ahead and circle that.
Are you gonna substitute now?
Okay, moving on. What line do you have to find this time?
The yellow one.
The orange, right?
Orange.
Okay, so let's take a look at the orange. Let's start again. Do you want to find a slope? Well, of course, if I don't give you the graph and just give you 2 points, then you have to subtract the 2 points to find a slope. But if the graph is already given, what can we use to find a slope without having to go through the subtract? Rise over run. So let's start with that. Here is the slope. Rise overrun. Go back to the graph and tell me, what do you do? If I start, remember we always start from the left going to the right, right? That's how we read, left to right. So we start from this point right here. Tell me, where do you go?
To the right.
Down.
Okay, let me just go back to this to the slope definition. It's
Down.
rise over run, not run over rise.
Oh.
So
Down.
there's no right or left first. It has to be either up or down, okay? So keep that straight. So from this point, where do I go?
Down.
Down how many?
7.
6.
7.
Okay, she said 7, you said 6. Let's verify. 1, 2, 3, 4, 5, 6. How do you get 7?
Kind of wrong. I know.
Okay, be careful, because if you actually going to be doing this on your test and you count it wrong, you will get the wrong slope.
There's too many
Okay.
boxes. That's why
And over here. Oh, we're not counting boxes.
I was counting.
We're actually counting the line here, the tick mark. You see it?
Oh.
We're not counting the square.
I know.
We never do that. We count the interval. Okay, in this case, where do we go now?
4. Over 4.
1, 2, 3, 4. See? 1, 2, 3, 4. So we going down 6, which is what? How do we represent down 6? Negative 6 and right 4?
Yeah.
Down.
Rise over run. Rise over run. Rise is up or down, right? Is that true? If you are rising, or you can actually go up or go down. Is that true?
Like you're in an elevator.
You don't write. You don't write
But
down.
if you are rise, we're talking about the direction of rise. Is that up or down only?
Yeah, that's just.
Okay, keep it straight. Okay, so can we reduce that? Negative 6 over 4. What is it? Negative 3 over 2. Okay. How? Okay, moving on. What else do we have from the orange line already? What else is already given for the orange line?
It's just the reciprocals.
Well, wait, we're not done yet. Look at the orange line. The
Y.
y-intercept is 8.
Wait, how'd you get 8?
There.
Oh.
Oh yeah, it is 8. Right. Wait, if the y-intercept is not given, what form do you use to find it?
The
If a regular point is given, that point what?
Point slope form.
Point slope. Thank you. Remember, if the y-intercept is not given, and I just give you the slope and a regular point, use the point slope form, which is the y minus box yesterday.
Oh yeah.
Okay.
Yeah, I remember that one.
Now, since we have the slope intercept and the slope and then y-intercept, what do we put back in here now?
The y equals mx plus.
Okay. And help me replace the variables to make it complete. Y.
Y equals 8x minus. No. Negative 3 over 2.
Negative 3 over 2.
X
X.
plus 8
Subtract 8.
plus 8.
Plus 8.
Okay. Oh, because this is positive. That's why I know it's plus. If it's a negative, I know it's subtract. Okay. So this is your slope intercept form. And how do I turn this into a standard form?
Add 3 over 2.
Okay. So it's going to be 3 over 2x over here plus y equals to 8. And we done?
Yeah.
Yes.
Done completely?
No.
What we have to do?
You have to cancel out the fraction.
Times everything by what?
2.
By 2. So if you times everything by 2, we end up with
3x
3x
plus 2
plus 2y equals to
16.
16. So this is our standard form, right? So I'm going to take that and write it over here. Y equals to negative 3/2 x plus 8 is our slope intercept form, and we have 3x plus 2y equals to 16 as our standard form. Now let's go ahead and analyze this for a moment. Wait a minute. Here we go.
No.
Oh no. Okay, go ahead and copy that down first.
What'd you do?
No, nothing.
You didn't.
Okay, you done for that part? Okay. So let's analyze this 3 lines and make a conclusion out of the 3. Okay. Can I erase this part?
No.
Now use the process that we just went through to find the equation of a line.
Yeah.
Okay. Don't forget, we have different forms.
Yeah.
Depending on what was given to you, you use a proper form. Okay. Let's take a look. Okay, let's analyze this for a minute. I said this to you before, that the purple and blue lines are what?
Perpendicular. Wait, no. Parallel.
Parallel lines. Okay, so I'm going to go ahead and write down, look at the two the two forms that I have. I'm going to use the same color as well so you can see. For the purple line, I have this. That's for the slope-intercept form. For the blue line, I have this. What do you notice about the two lines?
They both have the same slope.
They both have the same exact slope.
That's what I just said.
But what else is what else do you notice?
It's still the same y. No y's.
Oh, but they have
It's
They
only
never cross.
Different what? Different what?
Why?
Thank you. They have different y-intercepts. So let's conclude this. For parallel lines, you will expect to have same slope. That means if I know the slope of one line and I know the other one is parallel to it, I know that the other one will also share the same exact slope. You see it? And that you also have to have different y-intercepts. Why do you need to have different y-intercepts? Imagine if you have the same exact y-intercept. It means that the line are crossing over the exact same point. In that case, do we have parallel lines anymore?
No.
We have just one line right on top of the other one. Same exact line, so we don't have a parallel line in that case. So, for parallel lines to happen, you need to have same slopes, different y-intercepts. Okay, is that clear? So to verify if two lines are parallel, make sure that you can actually extract and put it back in the slope-intercept format. And compare the slopes, compare the y-intercept. Do they have the same slope? Different y-intercepts. If they meet the two conditions right here, you know for sure you have a parallel lines. Same slope, different y-intercepts. Okay? Now go back and analyze the orange line this time. So I'm going to go ahead and use the orange line. Let's erase this. Take a look at the orange line. I have y equals to -3/2 x plus 8. And this time I can use either purple or blue because since the purple and blue are both parallel to each other, I can use one to represent the other. Right? Let's use blue. The blue has this. What do you notice about the slope this time around?
It's opposite.
Okay, first of all, wait, who said opposite? Jamie. What do you mean by opposite? Okay, so you mean one's positive, one's negative, right? Good. So first of all, you notice that they're opposite each other. One positive, one negative, never the same sign. Second thing, what did you notice? If I take out the opposite part out, what do you notice about the two values? They're reciprocal of each other. So now, this is how we sum it up. For perpendicular lines, what? Wait, relax. Whoa. Must be the heat in this classroom. Relax. I gotta smell. For perpendicular lines, you notice that the slopes are what?
Opposite.
Slopes are opposite and reciprocal. Slopes are opposite and perpendicular to each other. Do you see that?
And what?
Perpendicular and reciprocal. Okay, so there. So slopes are opposite and reciprocal. It's right there. I just show you that case.
What about the 8 and 3?
Okay, we don't care about that. Okay, we just understand for a fact that the slope must be opposite and reciprocal. So for instance, if I give you, here we go, listen carefully, okay, and tell me what the slope is. Here's a line that has a slope of -2. Oh, you hear that?
Yeah.
I have another line that is perpendicular to the line I just gave you. What is the slope of the perpendicular line?
1/2.
Thank you, 1/2. See, you can actually figure out right away. All you have to do is follow this technique. Opposite, reciprocal. Because if I give you one line,
What does that seem so? But the sign or something.
then that's not perpendicular. For perpendicular lines, you must have opposite, reciprocal. There's no other way. Okay? Opposite, reciprocal. So for instance, once again, lamb, if I have a slope of 5, what is the slope of the line that's perpendicular to that line? Let's apply this. Thanks. Yeah, -1/5. So if the slope of one line is 5, then the other line has to be -1/5. You see it? Negative reciprocal. So opposite reciprocal. That's what I'm talking about. Any questions so far on parallel lines versus perpendicular lines? Okay. Good. So we're going to be using that technique. I want you to go ahead and take a look at your homework assignments for tonight.